Hey everyone, thanks for checking out this first ever Mechanical Magnificus build video in which I'll be showing you how to turn one of these keychain circuit boards into an extremely capable project controller for your breadboard circuits. I'm also going to be going over a few basic soldering techniques that I use every time I do something like this. Let's get started. Here are all the components used in this project. Now, before you open your search engine, you can find links to all these components in the PDF file for this keychain posted on both our Patreon or mechanicalmagnificus.com. At the time, these were the best prices that I could find. That's not saying that there are better prices now, but it should at least give you a good idea of what to look for. You're also going to want at least a basic soldering iron, some lead-free solder, a voltmeter and a battery pack, and lastly, an Arduino Uno and a breadboard. We're going to start by soldering a 28-pin socket to the circuit board, being very careful to line up the notches. Observe the notches. To hold it in place while soldering, I use just a tiny drop of superglue where the plastic meets the circuit board. With the socket held firmly in place, we'll start soldering by adding just a little bit of solder to the soldering iron. We'll hold it at a 45-degree angle to heat up both components at the same time and add solder directly to the components. It's always a good idea to check your solders every once in a while up close, just to make sure that you haven't missed any or that you don't need to add any more to any. These ones look fine, so I'm going to keep going. If you didn't plan on removing the Atmega 328 chip later on, you could solder it directly to the circuit board, but you have to be careful not to solder for too long without a break, or you risk damaging the component. And now it's time to add the crystal oscillator. This one slots in between the two ovals, into the slot with the strange runic symbol on it. And instead of using super glue, this time I'm just going to bend the leads back about 45 degrees. The pressure should hold it in place fairly well. And now to solder it in place. Now with safety glasses on, we're going to trim off the excess leads with a pair of sprue cutters or wire snippers. Now I'll turn the board over and add the capacitors to either side of the oscillator. And hold them in place the same way, bending up the leads, and solder in place. Trim off the excess, and then it'll be time to start on the buck converter. We're going to start by trimming off 4 male pin headers. Careful not to lose any, of course. With a better hold on the pin headers, I'll trim off 4 of them and then stick them into the breadboard to hold them in place while I place the buck converter on top of all 4, lining up the holes, and solder them in place. Buck converters are step-down voltage regulators. So because I'm using a 9-volt source and stepping down to a 5-volt source, I'm going to want to start with the voltage pretty low. So I'm going to take a screwdriver and turn that screw about a half turn clockwise. With the buck converter now hopefully set to a lower voltage than our source voltage, it should be safe to plug it into power. We can fine tune that voltage, however, using a voltmeter, probing between power out and ground. It looks like that initial half turn got me pretty close to 5 volts, so it's not going to take too much. Remember, clockwise takes your voltage down, counterclockwise brings you back up. I always like to shoot for just above 5 volts. To mount it, simply point the arrow in the direction of voltage out. This is the direction that current will flow through the buck converter. Once you've gotten that in there, the pressure on the pins should be enough to hold it in place while you solder it in place. But if it's not, you can use a tiny drop of super glue on the plastic sleeve covering the pin. And now to trim off the excess. Now we're going to measure out and trim some pin headers for either side of the board so that it can be plugged into a breadboard. To measure them, I like to stick them into the holes and then trim off what hangs over. As always, a tiny drop of super glue where the plastic meets the board is a great way to hold them in place while you get ready to solder. I won't make you watch the rest of the soldering. Let's skip ahead to where we put the resistor in. For this, you can bend the wires down so that it slots into the holes and lays flat against the board next to the capacitor. As before, the pressure on the wires should hold it in place, but if not, you can bend them up at about 45 degrees to help with this. Now we'll trim off the remaining leads and add the programming and power ports. We'll form these ports by trimming off one set of 3 female pin headers and 2 sets of 2 female pin headers. You can snip the block right in the middle of one port, just letting the lead fall out the end, and then trim them down with some wire snippers and sandpaper. This isn't completely necessary, but it helps them look a little bit nicer. As before, I've held them in place onto the board with a tiny drop of super glue where the plastic meets the board. With the last of the components soldered on, we can finally add our 328 chip to the socket and program it with an Arduino Uno. If your 328 chip doesn't already have the Arduino bootloader, I can show you how to burn the bootloader with the luggage tag in my next video. But for now, we'll assume that you already have the bootloader, and we'll begin the programming process by removing the 328 chip from the Arduino Uno by gently prying it out with a screwdriver. With that out of the way, we can connect our board to the Arduino Uno with jumper cables to the 5 programming in ports that we added earlier. With these wires in place, you can plug your Arduino Uno into the computer and begin programming. I always like to start by uploading the Blink script, which can be found in Examples under Basics. Now, before we can upload this code, we have to make sure that the board is in fact set to Arduino Uno, the one we're using to upload. Now, if everything is connected properly, you should be able to go to the Upload button and upload the code to the Keychain circuit board. There are quite a few errors that you can run into during this step, so if you do have trouble, let me know in the comments below, and I'll try to help you figure out what went wrong. Finally, I'll build the circuit to make sure that it works, by connecting an LED and variable resistor in series between pin 13 and ground. This is an extremely simple proof of concept given the capabilities of this board. In fact, this board could even be used to run a Robotail, which features 4 potentiometers, 4 servos, a radio receiver, and a triple-axis accelerometer with gyroscope. The possibilities are only limited by your own imagination. You can even use this without a breadboard for more permanent projects. Just check out the links after the video to learn more. Maybe you want a rain detector for your sprinkler system to save water, or an applause machine that responds to verbal cues. Whatever you end up doing, be sure to share it on all your social media with an @CalvinEngineering or #Magnificus so we can see what you did with it. Anyway, thank you so much for watching this video, and to my patrons for helping make it possible. Be sure to follow us on Twitter and Instagram for weekly project updates. And if you like what you see, consider becoming a part of the magic on Patreon and receive exclusive content and perks. Please let us know what you thought of this video, and until next time, be yourself and continue making life magnificent.